Asteroids are rocky remnants left over from the early formation of a solar system, and our own solar system has millions of asteroids. Most of them orbit around the Sun between the orbits of Mars and Jupiter in the region called the asteroid belt. These asteroids range in size from 1 meter across to 1,000 kilometers. The larger asteroids are thought to be surviving protoplanets which, if given chance, could have become a planet, while other ones, which are smaller, are thought to be fragments of larger bodies. Orbits of asteroids are affected most by biggest planet of our solar system, Jupiter. Jupiter has a large number of asteroids in its orbit called Trojans, and it sometimes acts as our protector. Its gravity is so strong that it slings most of the comets out of the solar system before they can get close to the Earth. But with great powers comes great responsibility, and sometimes it can nudge asteroids towards the Sun, where they have the possibility of colliding with Earth. And hence, asteroids can pose a serious threat to life on Earth. Around 66 million years ago, an asteroid traveling roughly 20 kilometers per second collided with the Earth. This released energy as much as 100 teratons of TNT, or beyond a billion times powerful than the atomic bomb dropped on Hiroshima. This wiped 3/4 of all life on Earth, including dinosaurs. This extinction even paved the way for mammals to become dominant life on Earth and made it possible for humans to exist. But another such event can once again wipe maximum life of this planet. This time we would be the victim. There are thousands of asteroids that have orbits that pass close to that of Earth, which can become dangerous for us. Or any event in the asteroid belt can send one of such space rock towards us. So how can we prevent this? The first step is to identify the threats. Not every asteroid is a threat to Earth. We first identify which asteroid has a high probability of colliding with the Earth by tracking them and predicting their future orbit. Once we find our target, there are several methods to deflect them depending on how early we detect them. The first method is to paint the asteroid white. If we detect the asteroid early on its path to the collision, we can paint the asteroid with white-colored material like titanium dioxide. This white-colored material will reflect most of the solar radiation, increasing radiation pressure on the asteroid. This can slowly but significantly alter the path of the asteroid. Another method is the kinetic impact. This method utilizes the impact of a massive object such as a spacecraft or another near-Earth object to knock the target off course. If this method is utilized when the asteroid is far from the Earth, its momentum can be altered. NASA has planned double asteroid redirection test or DART space probe, which will impact asteroid Didymos B. It is estimated that 500 kilograms probe will impact at 6 kilometers per second. This will produce a velocity range on the order of 0.4 millimeters per second, which over time will lead to a large shift of path. Another alternative is the gravity tractor. In this method, mass of a spacecraft is used to pull asteroid gravitationally. We can use engines on a spacecraft to pull asteroid in the desired direction. This method is slow but effective and may need a few years to produce effective results. Last and the ultimate method to deflect an incoming asteroid is to use nuclear missiles. In this method, a nuclear explosive device is strategically exploded near asteroid instead of vaporizing asteroid completely. The energy and shock waves from the explosion can push the asteroid out of the collision course. This method needs proper execution and planning, as a slight mistake can convert asteroid into pieces of radioactive debris falling from the sky. As Earth is the only place that humanity calls home, we have to protect this from any such dangers.